All right, so we're going to do a heat equation here. And the question is, if 335 grams, that's a mass, so I'm going to go ahead and label that in my givens, of water. So that's also important. So make sure you're writing down what the chemical is if it says it. If 335 grams of water at 65.5 degrees C, that means that's what we're starting at. We're starting at 65.5 degrees C. Loses is a negative, okay? Because we don't want to lose something. So loses negative 9750 joules. Oops, sorry. And that is our Q, because I know Q is for heat or thermal energy. What is the final temperature of the water? So my unknown is temperature final. So that's how I decoded that there. And then my equation. Each time you're going to be using the MCAT equation. Q equals MC delta T. Thermal energy equals mass times specific heat times the change in temperature. Okay, so what do we have? Q. Oh, we do have a Q. Okay. M. Do we have an M? Yes, we do, and it's in grams, so it's in the right units, so we are good. C. I don't have a C, but I know it's water. Water's C is 4.184 joules per gram degree C. Okay, that is the specific heat of water. So make sure you have your table written down that has all the common specific heats, because sometimes it's just going to give you a chemical. Delta T. Okay, well, I don't have a delta T, but I am looking for temperature final and temperature initial. Now, I could use the other version of the equation, which is MC times the quantity of T final minus T initial, but that's going to be more algebra. So if you like algebra, go for it. You get to do it in one equation. But if algebra is not your friend, then use the MCAT equation. Anytime it asks for temperature initial or temperature final, solve for delta T first. So let's do our substitute solve sig figs so we have our guess. Q, negative 9750 joules, equals M. M is 335 grams, times C. C is 4.184 joules per gram degree C. And instead of trying to write it out, temperature final minus temperature initial, I'm just going to leave the whole thing as delta T. Even though it looks like two variables, treat that as one variable. The variable is the change in temperature. All right, so let's simplify that a little bit here. Grams, temperature's in degrees C, so it's going to cancel degrees C. Joules is on the top on both sides of the equation, so that cancels. So I'm just cleaning up the equation here a little bit. 950 equals 335 times 4.184 times delta T. And I know delta T is always going to be in degrees C, so that's why I canceled that degree C there. Okay, now what do? Combine like terms. So 335 times 4.184 is going to give me 1401.64. Is that right? Yeah. Okay. And that's times delta T. I'm not going to do anything with sig figs with that guy yet. I'm going to wait till the end because I'm still on the same equation. If I switch equations, I have to do sig figs, but not until I switch. So now I have 1401.64 times delta T equals negative 9750. This is connected by multiplication, so I know from algebra I need to divide to get delta T by itself. And what I do on one side, I do on the other side. On the right side, these cancel because they're the same. 1401.64 divided by 1401.64 is just 1. And I'm left with delta T on this side. And I'm left with negative 9570 divided by, come on, 9750 divided by 1401.64. And I get negative 6.956137. Delta T, so degrees Celsius. So I substituted in here, and now I just went through the solve process. I have one more S for sig figs. 9750, no decimal, so not important, so 3 sig figs. 335, 3 sig figs. 4.184, 4 sig figs. It's multiplying and dividing, so 3 sig figs. I take the least sig figs. So 6, 9, and 5, so I'm going to be rounding from that thousandths. That 6 tells me I got to round the hundredths up. So negative 6.96 degrees C equals my change in temperature. Is that what the question asks? No, the question asks for temperature final. So in this case, you got to use the delta T equation at the end. Delta T is equal to T final minus T initial. So T final minus T initial is equal to negative 6.96 degrees C. What am I solving for? I'm solving for temperature final, because I have temperature initial way up here, 65.5 degrees C. So let me substitute that guy in. Temperature final minus 65.5 degrees C equals negative 6.96 degrees C. All right. Now I'm connected here with minus or subtraction. So to get him to the other side, I have to add. And what I do to one side, I have to do to the other side. So 65.5 minus 6.96. So if you didn't do your sig figs here, you're going to have a little bit of different answer when you're plugging in here. So do the sig figs at the end of this equation. Don't forget about the negative sign there. And that's going to give you temperature final is going to be 58.54 degrees C. Let's go back. What are my sig fig rules for addition and subtraction? Least decimal place. 6.96, 2 decimal places. 65.5, 1 decimal place. So my answer can only be 1 decimal place. So I'm going to round to the tenths. Nearest tenth, the 4 tells me I'm going down. 58.5 degrees C is my temperature final. Let's get that right up there. Okay. So make sure you're doing that 1 decimal place, 2 decimal place, least decimal places is 1. So my answer is 58.5 degrees C for temperature final.